Good morning. We are going to, I didn't see how rough my eyes look. Sorry about that. Um, we are going to finish up this convection cells thing. So if you go into your courses, go to period 3, scroll down to lithosphere, dynamic earth, and this convection cells thing will be right up at the top. We do have a lab check with this one. So let's go over the things that are important. You do need to open this up. Boop. We're gonna log in. All right, so just to go over things that we've already talked about that are going to be on your lab check. You guys put a clear drop and you put the probe into your beaker, this little beaker thing. All right. What relationship do you observe between the temperature and density? When the fluid gets colder, the density gets higher. I'm going to write, and it sinks. When the fluid gets hotter, the density gets lower and it rises. All right. Why do you think this is so? When the liquid is colder, the molecules move less and get denser. All right. So that's definitely going to be on there. Another thing, number 6, sorry, I deleted this by accident. Why do you think the liquid at the bottom of the beaker moves to the left and the liquid at the top moves to the right? So the burner is on the left side. So the water that is rising needs to be replaced by the water to the right. So it like zooms over and makes the circulation that we know of. Okay. All right. So we're going to go down here. You had to answer this on your own. We're going to go down here. We're going to turn the burner on, burner A to high. Let's make sure it's on high. We want to turn on advanced features. Got it. For the configuration, we're going to skip this. This is just what you're predicting would happen. Use the gizmo to model each scenario by dragging the burner to the left or right. In each case, set the burner to high. We're not going to do two burners. We're just going to do one. But we are going to set the viscosity to 0. So make sure this is at 0. We are going to show the velocity vectors. So make sure you click that. And then what you're going to do is you're going to move the burner. We're going to grab and slide it over, and we're going to push play. And you are going to draw on here the direction that these arrows are flowing. So on here, you can see, and I'm going to use these arrows. It goes up where the burner is, just like we've talked about. So it goes up, it goes over, goes down, goes across. All right, so that's what we're seeing there. I mean, that's what we would expect. Wherever it's hot, it's going to rise. All right, we then want to put it in the middle. So let's reset. Let's put it in the middle. And let's see what happens. Ooh. All right, so above the burner, it's going to go up. So let me get my arrows. Goes up. It's going to split apart. It's going to go down and come back. Right? It's going to cool off when it's furthest apart or furthest away. It'll sink. It'll become more dense where it's cold right here. And then it'll heat up and it'll continue doing that. All right, so that's what you should have there. All right. Why doesn't a convection cell? Let's move down here. All right, so we are going to look at some examples of this in real life. So right here, it's showing you what happens here. So in the mantle, what is the general pattern of magma circulation in the mantle? So where magma is warm, it is rising. Where it cools down, it sinks. All right. At the mid-ocean ridge, here I clicked at the mid-ocean ridge. All right, what occurs along a mid-ocean ridge? Well, magma is rising and the crust. Magma rises and the crust moves apart. What happens at a subduction zone? Right here, subduction. Right here, subduction zone. All right. The oceanic crust sinks. So, oceanic crust sinks back into the mantle. All right. So now we're looking at the ocean. So let's go ahead and click ocean. All right. That's the global conveyor belt of water. Click each of the orange dots to read what causes water to move up and down in the ocean. What two reasons causes the water to move downward in the North Sea? So up here, this is the North Sea. It says the formation of sea ice in the Arctic causes the ocean water to become saltier. So it caused the water there is saltier, which makes it more dense. Salt doesn't freeze with the ice. The salty cold water is denser than the surrounding water. The water is very cold in the North Sea, which also makes it denser. All right, what causes water to rise near the equator? Boop. All right, deep water gradually warms as it moves towards the equator, becoming less dense. The water becomes warmer, which makes it less dense. All right, that's where we're going to stop for now. When I get back, we'll talk about this more.